Hey everybody, welcome to part 3 of the time value of money lesson. And this, we're going to be expanding on what we saw in part 2. So in part 2, if you remember, we got into how to find the effective rates, how to deal with annuities and perpetuities. Now we're going to take it a step further and deal with something called growing annuities and growing perpetuities. And this will be the last new type of cash flow that we see. Later on, we'll see, or later on in this chapter, we'll see how to deal with the different types of loans. Specifically, we'll put an emphasis on mortgages. And then we'll do something called the net present value at the end. Okay, so that's kind of the breakdown of today. So let's start with what I even mean by growing annuities, right? So we saw that an ordinary annuity and an ordinary perpetuity have specific characteristics, and one of them was that the payment was constant, right? $100 every month or $200 every year and so on. Well, a growing annuity has all the same characteristics except for that one. A growing annuity and a growing perpetuity, they have payments that grow at a constant rate. The constant rate is what we call a G, the growth rate. So imagine that, and I have an example here, that we have a growth rate of 10%. Well, instead of every cash flow being 1,000, the cash flow in year 2 is going to be the cash flow in year 1, which is 1,000, times 1 plus the growth rate. We're going to add basically 10%. Then the cash flow in year 3 is going to be the cash flow in year 2, 1 plus 10%. So we often say that your cash flow in any given period, so let's say cash flow 1, is the period before times 1 plus G. And you'll find this useful in any situation where you have a growth rate. So you'll see this a lot when we're doing stocks, okay? The cash flow in any given period is the previous period's cash flow times 1 plus G, G being the growth rate, right? So we're just adding a percentage to it. So it ends up looking something like this. Now the formulas will change. And those of you using financial calculators are going to have to put it away because you cannot do this with a financial calculator because there's nowhere to enter the G. So we're going to do everything here by formula. I've also included both versions of the formulas, and I'll try and do this moving forward. I know that some of you guys learn it as you use the symbol K. Some of you guys use the symbol R. So I've included both. Okay, so you pick the side that you're on and go with that. But basically, there are 3 formulas here you want to know. The first one is probably the most, I would say the first and the third are the most common, most important. These are the ones you'll see in any book, basically. You have the present value of a growing annuity, and then the third one is the present value of a growing perpetuity. The one in the middle, Formula 2, this is a very specific formula for a very specific situation. You see, when you have a growing annuity or even a growing perpetuity, now you have 2 different rates. You have the discount rate, so K or R, depending what you call it, and you have G. And if those 2 are equal, it creates an issue. Because look at the formula, right? Look at the denominator. If you got your effective rate and your growth rate, and they're subtracting, well, you're subtracting the growth rate from the effective rate. And so if those were both the same, you would be dividing by 0. And we know that we cannot divide by 0. So you have this formula for exactly that situation. It replaces the first formula, but only, okay, and this is a warning, you can only do this when K and G are the same. In any other situation, it won't give you the same answer. Now, specifically for the perpetuity, if K and G are the same, there's absolutely nothing you can do. You cannot solve it. In fact, K absolutely, the discount rate, that means K or R again, absolutely has to be greater than G. In a growing perpetuity, your rate, your effective rate, absolutely has to be greater than your growth rate. And if not, it cannot be solved. Okay? So let's do our first few exercises here. So I'm going to clip, I'll grab both. Okay, so here we go. An investment promises to pay you $1,000 in 1 year. Okay, $1,000 in 1 year. And what you need to start doing, and what I do when I read questions, is I start to kind of have a filter in my head of what it could possibly be. So $1,000 in 1 year, so far it could be anything. 8% more each year. Oh, okay, so there's a growth rate. So now I've narrowed it down to 2 things. It could be a growing annuity, or it could be a growing perpetuity. And then it says for a total of 19 payments, now I know it's a growing annuity. So you see, just from that first line, I kind of have an idea of where this is going. I'm dealing with a growing annuity. What is the value? So what is the value? So we're looking for the present value. I didn't say how much are you going to have in the future or anything that would imply future value. I'm asking you, what is the value? The value is the value today. So I'm looking for the present value of a growing annuity. So I'm going to use my formula. The $1,000 is your first payment. So PMT1 or C1. So 1,000. Your rate is 12% compounded semi-annually. See, the things we learned in the previous lesson still apply here. And so I cannot use that 12% blindly. I need to ask myself, well, is that an effective rate? It's not, right? We talked about how if I give you a rate and I follow it by a compounding frequency, then that means it is an APR, right? An annual rate or a QR. And so we're going to go off to the side here and we're going to calculate our effective rate. So your effective rate, so again, K or R, is going to be 1 plus that APR over your compounding frequency, which they told us is 2, right? Semi-annual is 2 to the 2 minus 1. Now I'm finding an effective annual rate because the payments are annually. Again, if you struggle with this, it's important you go back and watch lesson 2 to really click with what I just did. I knew I had to find an effective annual rate because my payments are annual. It's very important for you to be able to do these questions. All right, let's punch this in. So you get about 12.36%. Okay, so that is your discount rate, and that's what we're going to use as our denominator here. Minus the growth rate of 8%. Now I'm back to following that kind of long formula. And then 1 minus 1 plus G, so 1 plus the growth rate, 0.08. 1 plus the discount rate, 0.1236. And all that to the power n being the total number of payments, which is 19. $12,122.88. That is the present value of this annuity. Okay, number 2. A stock will pay you a dividend of $5 next year. Okay, great. So if I were to put that on a timeline, again, you don't have to do timelines, but next year it's $5, and then 6% more each year after that. And you see, it never says it's going to change, right? So, or stop. So again, the filter in my head is, okay, 6% more each year, that's a growth rate. And then I read the rest of the question, and it never said it was going to stop. It didn't say, for 10 payments or for 20 payments. So this to me is a growing perpetuity. And so we're going to grab our formula for that. And you'll just punch it in, right? So you've got your first payment, which is $5, divided by the appropriate discount rate is 8% per year. You see here, I didn't give you an APR. I actually gave you the effective rate. I said 8% per year. I didn't say 8% per year compounded semi-annually or compounded monthly. So that's my rate. And then my growth rate is 6. So 5 divided by that is $25. That is the value of the stock. That is the present value of these dividends, yeah. Okay. Let's do another one. You will deposit $100 at the end of this month into a savings account earning 12% per year compounded monthly. So we know that our payments are monthly, so our frequency is 12, and we're also compounding monthly. We talked about this in the previous lesson, that in this situation, your rate, your discount rate, you could find it just by taking your APR and dividing it by your frequency or your compounding frequency. So if I did here 12% divided by 12, I know that I'm dealing with a rate, so again, K or R, of 1% per month. You plan on increasing your deposits by 1%. So there's your growth rate. And you see here we have a situation where your discount rate and your growth rate are the same. So this is the only time where you should be using this formula. Now, this formula is likely not going to be given to you by your in your textbook. I haven't really seen this in any textbook, but it's one that I think is pretty useful for these kind of sketchier situations, right? Little curveballs that they'll sometimes throw. So let's get into it. The first payment is 100 divided by 1 plus your discount rate of 1% times n being the number of payments. So for a total of 5 years. Now, if you're paying monthly for 5 years, your total payments would be 60. So let's do it. 5940.59. That's the present value. Except we didn't ask you for the present value. We asked you for the future value. How much will you have saved up? See, for this, you have to do it in 2 steps. And what's also important is that you read the question, because a future value of a growing annuity is actually a really rare question. But it's totally within the realm of what you have to know. But here's the thing. You always do it in 2 steps. If you want to find the future value of a growing annuity, step 1 is find the present value. Okay? That's what we did here. This is the present value at time 0 of that growing annuity. And your second step is to just find the future value of this present value. Okay? So this was, this was all part 1. Now, step 2, you're just going to use your basic future value formula. What I mean is future value equals present value multiplied by 1 plus k or 1 plus r, whatever you prefer, to the n. Okay, so you're going to take that present value, 1 plus your rate of, in this case, 1%, n is 60, and you're going to find the future value, because all the future value is, and we talked about this in lesson 1, all the future value is the future value of the present value. So if you know the present value of something, you can always find its future value by using your basic formula. Okay, so let me just shift this over a little bit. So you will have saved up $10,792.25. Maybe your decimals are a little bit different because of rounding, but that is the future value at period 60. So recap, you want to find the future value of a growing annuity? Totally doable. Step 1, find the present value. Step 2, compound that present value into whatever future value you want. Okay. Number 4, your business is expected to earn $20 million in profit next year. Okay. Let's put that on a timeline. Next year, we're going to get $20 million. But due to economic changes, you're expecting the profit will decline by 2% per year indefinitely. So what we have here is a perpetuity, first of all, right? Because of the indefinitely, that means forever. But with a growth rate that is negative. What is the value of your business today if the discount rate is 20%? So that's your rate. The point of this exercise is to show you that whether the growth rate is positive or negative, you treat it exactly the same. So since this is a perpetuity, I'm still using my perpetuity formula. Okay, the first payment is 20 million. I'll just put 20 with an M over my rate, which is also 20%, minus my growth rate. Now here's the only thing. Because the growth rate is negative, you need to respect the signs, and you'll end up having a double negative. So minus from the formula, and then negative again. So this works out to be 20 million divided by 0.22, right? We're adding. So you end up with something like 90 million. Right? You get 90.909 kind of repeating $million. Okay, if you had actually punched in all the zeros, you'd have 90,909,090. 91. That is the value, the present value basically of all your future profits. So negative growth rate, we call a shrinking rate sometimes. It's not actually anything different. Just make sure you respect the signs. Cool. Now let's talk about, so that was kind of the end of all the new techniques, mechanics, operations, whatever you want to call it, right? So different types of cash flows. Now we're just going to see different situations where you would apply them, situations where you would apply more than one, some certain contexts that you would apply some of these. Okay, so here we'll deal with moving cash flows. We say moving cash flows because you could change where your cash flow, like your annuity or your perpetuity, you can change where it starts. It seems odd, right? But you can. And really, this is a situation where, in the context of the question, the first payment is not in the first period. Pretty much all the questions we've seen so far, the first payment was in the first period, either at the beginning, which would make it an annuity due, or at the end, which would make it ordinary, or even, for the growing stuff. But when that first payment is not in the first period, now it becomes kind of a two-step process where you first find the present value and then you move it to the correct point in time. And again, it sounds weird when I say it that way, but watch me do it and just, always follow those steps. So let's start with the basic one. A cash flow will pay you $100 every 2 years, starting 1 year from today. Okay. So 1 year from today, we'll pay you $100. So this is time 0. This is year 1. This is year 2. And then every 2 years, it's going to pay you $100. And this will go on. It doesn't say it's ever going to stop. So we can assume that this pattern will basically go on forever. Now, before we solve it, let's talk about what the issue is. See, the issue you have here is that because the payments are every 2 years, right? Then technically 1 period is 2 years. So if you were to look at this as I'm going to draw it in red, okay? Technically it's like this. Period 1 is actually at year 2. And period 2 is actually at year 4, and period 3 is actually at year 6, and so on and so on and so on. So that first payment is kind of in an awkward spot. It is not at the beginning of the period, which it would have been if it was here at time 0. And it's not at the end of the period, because to be at the end of the period, it would have had to have been at time 2. So what do we do? What you would do in a situation like this is you would move this first payment either here, which is what I would do, and that's what we're going to do, or you could move it back, but I wouldn't recommend it. So we're going to move it. So essentially what you're saying is, I would prefer if this first payment was at time 2, because if the first payment was at time 2 and it was every 2 years, then it would be kind of perfect, right? It would be every 2 years at the end of every 2-year period. So how do we move it? Well, you move it with your basic future value formula. So we have a 10% discount rate per year. So I'm going to start by taking my $100 and I just want to add 10% to it. The formula I'm using is my basic future value. Future value equals present value multiplied by 1 plus the rate to the n. So that would be 110. And effectively what you've done here is you've moved it forward. So now it's as if it was at time 2. And now you basically have turned it into a 2-year perpetuity with payments of 110, but where the first payment is in 2 years. And now that might seem weird to you, but let me just explain to you what you're looking at. Getting $100 every 2 years with the first payment in 1 year from now, or getting $110 every 2 years with the first payment being in 2 years are exactly the same thing. They're equivalent. Mathematically, those two have the exact same value today. But the second one is easier to work with. So here's the second step. So step one was changing or moving your perpetuity to start at the end of the period, not in the middle. Okay. Now, because you have a 2-year pattern, your frequency is 2 years, we're going to need to convert our effective annual rate into an effective 2-year rate, right? Again, we learned in the previous lesson that when you're actually solving the present value of an annuity or a perpetuity, your discount rate has to match the frequency of your payments. So now is the part of the question where we're going to be dealing with the annuity or the perpetuity. So we're going to start by using our effective to effective formula. Because we already have an effective annual rate and we want an effective 2-year rate, we have a frequency of 1, but we actually want a frequency of 1/2. So we're going to use the formula. Remember, the kind of effective rate that we have, and then the old F divided by the new F minus 1. So 1 plus 10%, 1 over 1/2 minus 1. And that gives you, let's see, minus 1, 21%. Yeah, 21% every 2 years. So 10% per year is 21% every 2 years. Okay, so we found our rate. Again, we found our K or R. And now we can use the basic present value of a perpetuity, which is your payment over your rate. So it is 110 over 0.21. The present value is $523.81. So let's just organize this a little bit, or just space it out. So step 1 was to move it. Step 2, I found the correct effective rate to deal with the perpetuity. And then step 3, because it was an ordinary perpetuity and I had the first payment and I now had my discount rate, I was able to just find its present value. Okay, so this is a more challenging question, but if you review it and you understand what I did at the very first step, where I didn't want my payment to be in the middle of a period. I need it to be at the beginning of the period, not ideally, or more preferably at the end of the period. Why do I prefer at the end? So that I can treat it as an ordinary perpetuity. If I would have brought the payment back in the first step and started it here, that would be okay, but I would have to treat it as a perpetuity due. So it just adds another element. Okay, let's do another one. Now, we saw what to do in this particular situation where the first payment was in the first period, but kind of in the middle, right? Which is awkward. Well, now let's see a situation where the first payment is not even in the first period at all. So you will begin receiving $600 per month. Okay, so you have a frequency of 12, 6 months from today. So here's the thing. Here our periods are monthly. And in the first month, there's nothing. In fact, in the first 6 months, in the first 5 months, there's nothing. And then the first $600 payment is 6 months from today. So you see, you have here, again, a perpetuity, right? It doesn't say it's ever going to stop, but it starts in 6 periods. Okay. So in a situation like this, where I sometimes call this like a forward starting annuity or forward starting perpetuity, I'm not going to take the same approach as this. I could, by the way, but I won't. I don't like to do that. I'm not going to move the first payment. What I'm going to do instead is I'm going to find the present value of my cash flow wherever it may be on the timeline, right? So what do we have here? We have a perpetuity, which means our present value is the payment or the cash flow over the rate minus the growth rate. Again, or you can use PMT over K minus G. I'm just, alternating a bit for you guys to see that these two are really the same thing. Okay, so the first payment is 600. The rate, they said 8% per year compounded monthly. So I have monthly compounding and I have monthly payments. Great. There's that situation again where I could just take my 8% and divide it by 12 because my M and my F, my compounding frequency and my effective frequency are the same. So I get 0.0666 repeating. So I'm actually going to keep it as a fraction just because I want to get the exact number. So that's my rate minus G. There is no G. Sorry. There's no growth rate. So let's back that up. All right. It's just constant. Great. Even better. So 6,000 or 600 rather divided by that is 90,000. Okay. So step one was I'm going to find the present value. But here's the thing, and this is very important, okay? And this is going to happen here for the first time together, but it will happen a lot, especially when we get into stocks. Just because you find a present value using a present value formula doesn't necessarily make it the present value today, okay? The formula has no idea what you're doing. You're just plugging in numbers. And so if your first payment is at times 6, well, the present value that you just calculated is not at times 0. We used the formula for the present value of an ordinary perpetuity. And we learned that in an ordinary perpetuity, or even an ordinary annuity, the present value is one period before the first payment. Because the first payment is at the end of the year, right? So technically this is at the end of time 6. And the present value is right here at the beginning of time 6. So what you just found is actually the present value, sure, at period 5, which is not what we asked you for, but it is the correct first step, or we can get to the answer with this. So when you have a situation where the first payment is in the future, okay, your first step is just, okay, deal with it normally. Find the present value, use the appropriate formula. And then the second step is to just move it to where you want it. Well, I don't want it here at time 5. So this now is actually going to become a future value, right? Because I'm going to take it and bring it back to time 0. So I'm going to use my basic present value formula, which is future value divided by 1 plus my rate to the n. And that's going to be my future value. 90,000 divided by 1 plus the rate. In this case, the rate is this. So 0.08 over 12. And then n, it's 5 years at... it's actually just 5 months, right? Yeah, good. This is already in months, so 5. So I almost made that mistake there, right? Be careful when you're drawing this. Don't forget what you're dealing with. These are in months, so it's not 5 times 12. It's actually just 5 because if the n has to be in months and your k was already in months. Your rate, right? This thing here is per month. Okay, so we can punch it in now. This is divided by 87,059 and 8 cents. And that is the present value at time 0 of this perpetuity that technically only started, 5-6 months from now. 2 steps. Find the present value and then move it to wherever you want. Okay, great. Now we're going to get into... Hey everybody, sorry to interrupt. I just wanted to quickly ask you guys to follow me on Instagram. You can use the QR code here. You can type in my username. It's really the best way to reach me for questions if you do have any. If you wanted to have access to me more regularly, chat about certain things, talk to me privately, Instagram is really the best place to reach me. Loans and mortgages. So we're going to talk about different types of loans, but the emphasis will be on mortgages and installment loans because those are really the main ones. So, of course, we know what a loan is. A loan is you borrow money from somebody, the person charges you interest, or the bank charges you interest. You agree on terms. I'm going to pay you back in 5 years, in 10 years, in 20 years, and then you pay them back, hopefully. Now, the most common type of loan is called an installment loan. And this has many names. Sometimes we call it a blended payment loan. Okay. The reason it gets that name is because in a typical installment loan, you have a constant payment. So for example, you buy a house or you buy a car. Every month, you have to make the same payment, maybe $1,000. But a portion of that payment, okay, if I were to kind of draw it out, right? You have $1,000. Let's say that's your payment. A portion of that payment is interest. And let's say, I'm just going to make this up, okay? Let's say that the interest portion is $700. That means the remaining $300 is principal. The principal is actually what goes towards repaying your debt. The interest is the interest that you owe the lender. So when you go to the bank to make your payment, the bank will calculate how much interest you owe, let's say $700, and they're going to deduct that from the payment. Say, oh, thank you for your $1,000. We're going to take $700 out because you owe us interest. That money's lost, okay? Belongs to them. The rest will actually go towards reducing your debt. So we call that the interest portion and the principal portion. And usually, and basically how it works, the interest portion, and I'll show you with this table here. Okay, these are called amortization tables, by the way. And the constant payment, the most common, is here. So let's say you borrowed $50,000, and you are going to repay it in 4 annual payments with an 8% interest rate. Well, you would start off with a balance of $50,000, and your payments would be $15,096.04. I'll show you how to calculate that after. Okay, every year. Well, in the first year, you're going to owe the bank 8% of $50,000, which is $4,000. So you see, they're going to take $4,000 out of your payment, and then the remaining $11,096 is called the principal, and that's what will actually go towards reducing your debt. So look at what happens to your remaining balance. It basically will decrease by $11,096. So now you only owe $38,000. So in the following payment, your payment doesn't change. It's still $15,096, but now you only owe interest on $38,000. So you see the interest portion is decreasing with every payment because your balance is decreasing with every payment. And consequently, your principal portion is increasing every payment because there's more left over to pay off your debt. And at the end, you've paid it off perfectly. That's how these loans work, okay? Now, other types of loans that are a little bit less common are interest-only loans, where you only pay interest. So this basically follows what we call simple interest, because the interest you pay is always the same, and it's on the amount that you borrowed, right? So 50,000 times 8% is 4,000. And that's all you have to pay. And since that's all you have to pay, you're not actually reducing your debt. So next year, you still owe 50,000, so your interest is still 4%. And that basically will continue. And at the end, on the final payment, you're going to pay, there should be 5 here. You're going to pay 54,000. You're going to pay off the last bit of interest and the principal that you owe, the amount. Okay, so interest only interest until the very last period, and then you're paying off the entire debt. Another one that's also pretty rare is still a blended payment, so where you have an interest and a principal portion, but where it's the principal payment that's constant. Super rare. Like, never go to this unless they specifically said you're using a constant principal. Now, the way this works is you take the amount that you borrow and you divide it equally into however many payments. So if you have 1, 2, 3, 4 payments and you divide this by 4, basically you're saying you're going to pay off 1/4 of that every year. But you also have to pay your interest. So again, 8% of 50,000 is 4%, is 4,000, excuse me. So in this case, what's happening is these two added up determine what your payment is. So in the first year, your payment is 16,500. But because the interest portion is declining, your payment is also declining. Okay? So I'm going to warn you one more time. You should always assume that an installment loan has a constant payment, okay? Unless you are specifically given the instruction that it doesn't, that it has a constant principal, which is very, very rare. And in that case, you deal with it the way I showed you here, by taking your balance, whatever it is, the amount you borrow, dividing it by the number of payments. And then every period, you're adding interest based on the previous balance. Okay. So the exercise we're going to do is on a typical installment loan, and that is, following the constant payment pattern, and it's going to be a mortgage. So for that, actually, I want to talk to you about mortgages real quick. A mortgage is simply an installment loan used to purchase any real assets, so buildings, machinery, and so on. Mortgages typically have 2 time frames. They have the term and they have the amortization period. It's the amortization period that we care about the most, right? This is really the one that determines how long you have to pay back your debt. So the N in the question, the number of payments, is based on your amortization period. The term is something in mortgages where this is how long the lender will keep your payment constant. After the term ends, so it could be 4 years, 5 years, 6 years, in it could be even 30 years. U.S. mortgages are much longer than Canadian mortgages, so depending on what you're dealing with. But let's say you have a 5-year term. It means that your payment will be the same for 5 years. And then after 5 years, your payment will change. So the lender will look at what the interest rates are 5 years from now, and they'll give you a new payment. And then for the next 5 years, that'll be your payment. So let's say your amortization period ends up being 25 years, right? Like in this one, I think it's 25. Yeah, 25. It looks something like this, right? So you've got 25 years to pay off your debt, but every 5 years, you're getting, this is like term number 1, term number 2, 3, 4, and 5. So every 5 years, your payment is going to change. It's just how mortgages work. It's how banks protect themselves from interest rate risk, right? They don't want to give you, like if the interest rate happens to be really, really low at the beginning, well, they don't want to guarantee that rate for 25 years. And it's even good for you when the rates are really high, right? Like if the rates are really high at the beginning, you don't want to be stuck on that rate for 25 years. So now that's what the term is conceptually. Technically, or in practice, you should not be using that number for anything. When your mortgage payment is calculated, the term of the mortgage does not play a role. The term could be 5 years, 6 years, 7 years, 8 years. Your payment would be exactly the same because the payment is not based on that. The payment is based on your interest rate, how much you borrowed, and your amortization period, the total amount of time that you have to pay off your debt. So you really want to be careful when reading mortgage questions. If they give you a term and an amortization period, the amortization period is what you should be using in calculating your payment. Now, as far as how to do it, if you're using a financial calculator, or if you're using a formula, it's pretty much the same approach. An installment loan is an ordinary annuity, and you're solving for the payment. So let's say you were using the formula. We know the formula for the present value of an ordinary annuity is the payment or the cash flow multiplied by 1 minus 1 plus your rate to the power negative n over the rate. Okay? But you're solving for this. So what you can do is basically rearrange this formula and bring that entire bracket underneath the present value. And that's what you'll get. Okay, so let's run through this question. You just accepted, your offer was just accepted on a $1 million home in Toronto. You will put down a 20% down payment. So now what this means is you're not actually borrowing the full $1 million. The home was $1 million. You put down a 20% deposit, so you're actually going to borrow the rest. So you're borrowing the remaining 80%. So your loan is actually $800,000, 80%. And the loan is the present value, right? When dealing with these questions, your loan is the present value. So the present value is $800,000. Okay, divided by. BMO has quoted you a 5-year fixed rate of 5.6%. That's your APR. Mortgages are always quoted as an annual percentage rate. And it has semi-annual compounding. Why? This is part of the theory, okay? Canadian mortgages, and I have it written for you here. Canadian mortgages are compounded semi-annually. So because this says Toronto, it's a semi-annually compounded mortgage. A U.S. mortgage is compounded monthly. So we have here semi-annual compounding, but we have monthly payments. So we're going to find our effective monthly rate by using our effective rate formula. So 1 plus the APR, 0.056, divided by your M to the power M over F minus 1. So we're looking for our effective rate here. Again, you can call this K if you prefer. It's the same thing. Okay, so I get 0.004613. All right, that's my effective monthly rate. So now I'm just going to go back into this formula and continue what I was doing. So 1 minus 1 plus that number, 0.004613 to the power negative n. So negative n here. If you have a 25-year amortization and you're paying monthly, your n is 300. And again, those of you that are going to use the financial calculator, don't skip over this part because everything is the same as far as like what your K is or what your rate is, what your N is. Everything is the same. You're just going to punch it into the financial calculator. So there. Now, if you are going to use the financial calculator, this is what you're doing. You're entering your present value as 800,000, right? Same as the formula. Your N, same as the formula, 300. Your IY, same as the formula, except you need to multiply it by 100 so you can enter it as a percentage. So 0.4613. Okay. Just don't forget that times 100. Your future value is 0. Compute your payment. And it doesn't matter if you take this approach or you take this approach. You should get the exact same answer. Okay, so let me get my financial calculator out. 800 present value, 300N, 0.4613 IY, 0 future value, compute payment, 4,929.72. Your monthly payment is $4,929.72. Great. Now, you may get questions like, how much of your 18th payment will be used to pay interest, like the question B? And this goes back to what we were talking about here. You see, in this amortization table, The payment is constant, but the interest portion is changing every year. And so is the principal portion, and so is the balance. So what if I asked you, well, what is the interest portion of your third payment? Like here I can see that it's $2,153. But what if I asked you the 18th payment? So what I want to show you next is how do we actually calculate these values without having to make the whole table? If you're on a financial calculator, it's extremely simple. I'll do that one first. You have an amortization function on the calculator. So after you've computed your payment, you would press second and then the amortization, so amort, which is above the present value button. And then you're going to have on the screen P1 and then P2 after that. This is where you're going to enter 18. This is just how the calculator works. So the calculator is essentially asking you, well, what payment are you interested in? I'm interested in the 18th payment. So you're going to enter 18 for both of them and then basically arrow down. Okay, so if you're doing this on the financial, follow along with me. I found my payment, then I'm doing second amort, so second PV. And here's where you're going to put 18, enter to save it, down, 18, enter again to save it, down. Okay. So this is your balance. Basically, this is this column. So we know that after 18 payments, you still owe 776. Anyways, I wasn't interested in that, so I'll go down one more. This is the principal portion. That's actually answer C. Your principal portion of the 18th payment is $1,340.18. And if you go down once more, you'll get the interest portion of your 18th payment, which is $3,589.54. You see, like I said, with a financial calculator, it's really, really nice because the calculator will do all the work for you. And one more time, what it is that we just found these numbers. But for the 18th payment specifically. Now, if you're doing this, if you're not allowed to use a financial calculator or you prefer not to, you can do it. So I'll walk you through the steps. To find the interest portion, there's probably a few ways that you can do it. I guess how I would do it would be, I would start by finding my balance one period before. So let's start with that. How do we find the balance, right? Well, to find the balance, what you want to do is change your N to the remaining payments. So what I mean by that is, let's say we started with 300 payments. You know what I'm going to do actually? I'm going to start a fresh kind of blank page here for us not to get too lost in our work. Okay, so I'm trying to find here the balance after 17 payments. Okay, and I'm doing this because I want to find the interest and principal portion of the 18th payment. So listen up. Start by taking your N, which started off as 300, and removing 17 from it. So this will give you 283. There's 283 remaining payments. And then you're going to solve for the present value. So back to our present value formula, okay, this one here. Because this is an ordinary annuity, I'm still using this formula, but I'm going back to the original because now I'm actually looking for the present value. Because the present value represents how much you owe, right? So if you want to know how much you owe after making 17 payments, essentially what I'm saying is, well, you know now that the payment is $4,929.72, right? So $4,929.72. You know your rate hasn't changed. It's still 0.004613. Your N is what's changing, so you're changing that to 283. And then your R. So if you want to find your balance after any particular number of payments, just remove those payments from the initial and solve for the present value. Okay, so let's try that. 4929.72 times So my present value, after 17 payments, is $778,135, and if I round that, I get 38 cents. Okay, so this is how much you owe after 17 payments. The interest portion of any payment is based on the previous year's balance. So if you wanted a formula for interest, the interest portion, it's basically the balance from the period before, so balance T minus 1 multiplied by your rate. So if you wanted to find your interest at time 18, you would take the balance at time 17 times the rate. And that's what we're doing. We're going to take this number, $778,135.38, and we're going to multiply that by the rate of 0.004613. I get 3,589.54. Let's compare with what we found before with the calculator. 3,589.54, exactly the same thing. It's just more complicated when you don't have the financial calculator doing all the heavy lifting. So key things to take away here, right? The interest portion. And I explained this before with the table, but now you see it with a formula. And if I go back to the table, you see the interest is just based on your previous balance. Whatever you owed after the previous payment, right? That's what your interest for the next payment will be worth. And then your principal for any given payment is just the difference between the payment and the interest portion. So if our payment is $49.29.72 and your interest portion is $35.89.54, then the principal portion is $1340.18. That is the principal portion of the 18th payment, which, if you look, was pretty much the same thing here. Okay, so a little recap of the steps. If you are looking for the interest portion or the principal portion of the 18th payment, I'm using 18, but it could be anything. Start by finding your balance the period before. So in this case, 17. Use that to find the interest portion, and then use that to find the principal portion. And there are multiple ways you can do this, by the way. This isn't the only way to do it. It's just a way to do it. And if you always do it, then this will always work. Okay, what is your balance at the end of the term? So the term, remember in the question, was 5 years. So they're essentially saying, what is your balance after 5 years? Well, the balance after 5 years, if you're going to be using your financial calculator, all you need to do is set your P1 and your P2 to 60, right? Because 5 years times 12 is 60. So they're essentially saying, after you've made 60 payments, what do you still owe? So what's your balance, right? So if I go to my financial calculator and I just go back here and I make this 60 and 60, I still owe $714,556.58. Okay, so that's kind of easy. Now, if you're using the formula, it's actually not hard either, right? We just saw how to do it. What you're going to do instead is you're going to redo this. But your N is not going to be 283. Your N is going to be, right, 300 minus 60, 240. Always use the number of payments you have remaining. And you see, I'm going to do it on my calculators just to show myself and you guys, I guess, that it's the same. 4613. The power of negative 4, 240. I got exactly the same number. Maybe I was off by a few pennies. This is probably because of rounding. So 714.58 556 and 21 cents. Now, you're always going to have a little bit of rounding baked into your answers when you're using formulas. The financial calculator doesn't have any rounding, so that's the reason for the discrepancy here, not something you need to worry about. Okay? So if you want to know at the end of the term, just find the present value based on how many payments are remaining. Great. There's one more part to this question. A mortgage renewal. So as I explained earlier, when you take out a mortgage, and this mortgage, remember, was 25 years, right? And our first payment for the first 5 years, we had it. It was $4,929.72. We paid that for 5 years. And we know that at the end of those 5 years, based on our previous answer, we still owe $717,556, right? So the renewal of the mortgage happens at the end of the term when it's time for the bank to give you your next payment for the next 5 years. So suppose that you renew your mortgage at the end of your term and the interest rates have fallen to 4.4. What is your new mortgage payment? So this is how this works. Basically, you're starting a new mortgage. So it's like you're starting the question over again, but you have 20 years left, right? And your remaining balance from the previous mortgage becomes your present value now. And then you're solving exactly the same way, right? So if I go back and I just grab this, I'm going to be using this again. So paste. My present value now is $714,556.58, and maybe you're using 21 if you're using the answer from before. 1 minus 1 plus, and then the rate we have to recalculate it because the interest rate changed. So we're going to do the same thing. 1 plus the APR over 2 to the 2 over 12. So now your rate is 0.003634. And your N is 240 because there's 20 years remaining at 12 payments per year, so 240. All that divided by 0.003634. And the more decimals you use, the better. See, I'm using 6 decimals because when you're dealing with large numbers, that's 6. You see here, the 6th decimal can actually make a difference. Okay, so we're punching this in, and we're getting our payment. For those of you doing it on the financial calculator, you're basically following the same thing. The present value is the same, $714,556.58. The N is 240. Your IY, multiply that by 100, 0.3634. Okay, multiply this by 100. Future value 0. Compute your payment. I get a payment of $4,467.12. So this now becomes your payment for the next 5 years. Great. Okay, so it can be complicated at first, but once you get the hang of it, these types of questions are very, very repetitive, right? There's really not that much going on. These are always ordinary annuities, so they're pretty straightforward, especially if you have the financial calculator, it's even easier. Okay. Now, the last part of today's lesson is something called the net present value. And it really isn't anything new. We're going to be using all the different things that we learned in the time value of money chapter. But what makes it net is that we have here inflows and outflows of cash. Now, in a typical investment, you don't just get money. You also have to pay money, right? So when I ask you to find the net present value of something, I'm essentially asking you, what is the present value of its inflows minus the present value of its outflows? And we use net present value to evaluate investments, because investments that have a positive net present value are good investments. They're investments that you're basically getting for a good deal, right? We sometimes call these underpriced investments. So imagine buying a home for below market value, right? That would be a good deal, right? That would be a positive net present value. Or, buying a stock when it's underpriced. Getting a good deal on anything really gives you a positive net present value. So the formula is present value of inflows minus present value of outflows. Let's solve this first question. A new truck will cost you $100,000 today. So this would be the outflow. This is what we would call the cash flow at time zero. Okay. And it's expected, and if I were to put this on a timeline, right? At time zero, I'm basically spending $100,000. So I'm showing it as negative. And then it's going to generate $1,000 each month for 5 years. So month number 1, I'm going to get $1,000. Month number 2, I'm also going to get $1,000. And this will continue for 5 years, so for 60 months. And at the end, I plan on selling it for $12,000. So on top of that, at the end, I'm going to get $12,000. Your discount rate is 9%. What is the net present value of the truck? So what we have here, I'll highlight in green. Those are all inflows. And then the outflow is at the start. So to find the net present value, I'm going to start by finding the present value of all my inflows. And then I'll subtract from it $100K. All right? And then you start to go into your repertoire of formulas. Okay, so what do I have here? I have 1,000, 1,000, 1,000. That's an ordinary annuity. So I know to find the present value, I'm going to use my ordinary annuity formula. Or I'm going to use my financial calculator. So I'll do it once with the formula and then with the financial calculator. So if you are using the financial calculator, you can skip ahead if you want, a few seconds. So the first payment is 1,000. Actually, I'll keep going. So there's the annuity portion, and then there's this here. Now that's just a lump sum because it's happening just once. So on top of that, I'm going to have a future value that I'm going to discount back to the present day. So you see, this portion is for the $1,000 repeating, and then this part at the end is for the lump sum. So we can punch it all in together. 1,000, 1 minus, 1 plus the rate. They said the rate was 9%. Oh, but again, you want to be careful here. 9% is per year, but your payments are monthly. Always, always, always be paranoid that they're going to get you there. So I have to actually convert my effective annual rate into an effective monthly rate. I need my rate to always match the frequency of the payments. Okay. So we're going to put that on ice for a second and go and find our effective rate. So if I take the effective rate that I have, the old F, which is 1, and the new F, which I want, that's 12. Remember the formula? Old F over new F. Remember the formula I'm using here is basically 1 plus the effective rate that you have, old F over new F minus 1. So 1.09 to the power 1 over 12 minus 1, 0.007207. That's the rate you're going to use. So I'm going to go back and continue. And we have a total of 60 payments, right? Because it's monthly for 5 years. Future value is 12,000 over 1 plus your rate to the power 60. Okay. So that's how you do it by formula. On the financial calculator for this first step, You're going to enter your payments as 1,000. Your future value is 12,000. Your N is 60, and your IY is 0.7207. You see, there's really, really, really no difference. It's all the same things. You're just telling the calculator, and then the calculator just deals with the formula. Okay, so let's go. I'll use the financial just because it's quicker. Payment, future value, 60N, 0.7207 0.7207 IY. Compute the present value. So you would end up with a present value of 56,371, and you should have the exact same thing with the formula. Okay. Now that's not the answer. That's just the present value of all your inflows, right? That's kind of all of that. To find the net present value, you need to take that number now and subtract it by the outflow. So basically your NPV here, and in this last step, doesn't matter if you're using financial calculator or regular calculator, for this step it'd be the same. You're going to take the inflow of 56,371.01, and you're going to subtract the outflow, which in this case was 100,000. And you'll see that in this case, you have a negative net present value. So this is a bad investment. This means that you're paying today more than the total value that you're going to get from this purchase. So effectively buying this, what are we buying here? A truck? Buying this truck today is going to lead to a loss of $43,628.99 over the next 5 years. So you would not buy this truck. It's too expensive. So let's take that same concept now and do a more challenging question, right? Because this one was kind of basic, right? Just basic present value subtracted by 100K. Let's do this one. You're considering buying a new building to add to your real estate portfolio. To buy it, you would have to give a $500,000 deposit today. Okay, so today we're giving a deposit, so this would be an outflow. So I'll put here negative 500,000 and pay an additional 1.5 million when the deal closes in 9 months. So 9 months from now, you're paying another 1.5 million. So I'll put 1.5 million is 1,500,000. 1 year after closing, you expect to earn a profit of 100,000. So 1 year after closing. So this would be at month 17, right? Because I'm doing this in months right now, I might change this, but I added 12 months. I'm going to receive 100,000. And this will increase by 4%